Okay, so now hopefully it's going to grab the whole screen and record. We'll see how this goes. Because we have a lot of lessons left to do this year. Apparently there's some licensing thing that they have to make sure works. Okay, I'm gonna hope for the best. Otherwise, it's last year's and the years before for videos. All right, so we're still working on law of cosines here, but we found out there are some really good formulas for area of triangles for side angle side and side 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 situations, which make life a lot easier if you're taking some kind of time test. So understand and use the law of cosines to solve triangles. We have to know that law of cosines is for side angle side and side side side. And then using those new area formulas when we can. Finally, we're going to look at the applications, the word problems today. And we're really only going to go through 3. And if we, gosh, this is the whole if they get the recorder working, because I was going to save the exploration for tomorrow for your video. It'll be on a video one way or another. So here we go. When we did Heron's formula yesterday, I was thinking somewhere in our resources, and it might have just been in the ACT prep or the MCA prep. We need this reminder because every once in a while they'll give you 3 sides and they'll say, use Heron's formula if you can to find the area of the triangle. So you need to add this little piece to your notes here because it's been a while since you guys took geometry. And I don't know if this is covered in the spring. But it might have been one of those things where you did have a video lesson, and so you're not necessarily retaining it as well as in the past. Big reminder from geometry is, in order to form a triangle, any 2 sides of the triangle have to add to more than the 3rd side. That is an absolute must. So in geometry, they would give you 3 sides and they would just ask, can you form a triangle from these sides? We've been through that already, talking about the ambiguous case with side-side angle. But one of the big reminders when you're using Heron's formula is any 2 sides have to add to more than the 3rd side. So if they were to give us this set of sides and say, can a triangle be formed with these sides? If so, use Heron's formula to find the area. We would have to say what? Can't form it. 3 plus 5 is equal to 8. It's not greater than 8. There's no triangle that's going to form there. So again, like I said, I was thinking about it last night. I don't know if it's in the ACT prep that the other classes do or the MCAs, but it's an important reminder. Any 2 sides of a triangle have to add to greater than the 3rd side. So now we're down here. And this is the word problems, although this one I don't know really fits the definition of a word problem because we have a picture here to go by. So a tunnel is to be built through a mountain. To determine the approximate length of the tunnel, an ambitious math student with a homemade transit takes 2 measurements from a fixed point, as shown in the figure. Reminder, a transit is what surveyors use to figure out the angles and where they need to go with roads and bridges and such. So use the student's data to determine the length of the tunnel. That's why I said this one is not necessarily a word problem because there's a picture over here with it, How nice of them, because that clears up everything for us. We look at it and we see, hey, this is side, angle, side. I have to use law of cosines for this one. And what am I looking for? I'm looking for this. And since it's across from C, that's lowercase c. So is it a word problem? No, really it isn't. You really wouldn't have to read any of that up there except for the part where you need to know that this is the length of the tunnel. And you look at the picture, and I'm going to use law of cosines. So lowercase c squared will start with c and end with c. And in between, we'll have a's and b's. And we'll go ahead and solve this for c by taking the square root of both sides. And then we probably just want to label everything so we can get it in there. So lowercase a is 212. Lowercase b is 388. And the measure of angle C is 82.4 degrees. Let's plug them in, see what we get. 212 squared plus 388 squared minus 2 times 212 times 388, cosine of 82.4 degrees. And then we are going to take the square root of that big monster. Now, when we first started all of this business with the recordings, I had told everybody the graphing calculator, had glitches on it. And it's been working great up until yesterday afternoon. So for some reason, I'm either not pressing hard enough or I'm pressing too hard. It's not grabbing zeros. So I'll have to slow down a little bit to make sure it's grabbing everything that I'm punching in. So 212 squared plus 388 squared minus 2 times 212 times 388 times the cosine of 82.4. Second square root of that monster, 416.810 to 3 decimal places. And this information was given in feet. There's a label in the picture. So there it is. So again, it is a word problem, but it isn't. They gave us the picture. So that's the reason that when you turn the page, you see that we have an entire page for what we have to do on the next one. Because this one is truly, you have to read everything. You have to figure out the angles. You have to figure out, the distances, all of that stuff. And so it's going to take us a little more space to do that. And I want to remind everybody that heading is measured just like bearing. Remember, bearing is from due north. So when we read these angles off, we need to think from due north, what's going to happen here. And as people come back in, I'm going to have to make sure that their passes get cleared here so that they're not looking like they've been gone for an hour. All right. So here's where we start. An airplane sets out from the airport on a heading of 20 degrees. So here's my due north. And the plane is heading this way, 20 degrees from due north. Now, I want to just focus on the angles first, then we'll come back and talk about those distances. After an hour, they change their heading to 40 degrees. So here's due north. Now they change their heading to 40 degrees. After another half hour on this new heading, he lands at his house. So here's the house. Well, let's call this one A for airport, and let's just make this one B. but that's going to be where the house is. What is this distance from the airport to home? Well, that means there's our triangle being formed right there. In the morning, when he leaves his house in his plane to return to the airport, at what heading should he fly to get there directly? So I'm going to see if this will let me move. Yeah, with all of this going on. I'm going to make magnified pictures of what we need for this anyway, so I'll just leave it sit as it is. Here's our problem. So far, we don't have any labels for anything that's inside the triangle, and we have to figure that out. So let's go back and look at distances first, and then we'll put together the rest of what we have here for angles. So it said they were flying at 200 miles per hour for an hour at 20 degrees. Well, we know distance equals rate times time, but I'm going to have two distances, so I'm going to put a little sub 1 on there. So for the first distance, we've got 200 miles per hour for 1 hour, and that's going to give us a 200. So at least we have something labeled for our triangle now. That side is 200. And when they change direction after another half hour, so distance 2, 200 times a half is 100. Good news, we have 2 side lengths. Still not enough. We need more information. And what would be really nice would be if we knew what this angle was, and since this is A and this is B, let's label this one C, because we need this little distance, because they want to know how far are they from that airport that they started off at. All right, so this means I have to try to find an angle. And it seems to me I have a lot of information up here about what's going on. So that's the angle I'm going to focus on. That one right there. And now when you're talking about real life problems with heading or bearing, it's usually a good idea to think about that compass drawing and how that would fit into all of this with your due north piece in there. Because they told me that this was 20 degrees. And since these due norths would be parallel to each other, that tells me this is 20 degrees because those are alternate interior angles for parallel lines. Then let me draw on east and west so I can start thinking about the other things that were happening. And the other things that were happening were they changed course from 20 degrees to 40 degrees. Oh, well, now I can figure out what this one is because compass headings break it into 90-degree, 90-degree angles. So this is 50 and this is 90. Hey, if I add all those up, I'll have that big obtuse angle that I need. So 20 plus 90, 110, 110 plus 50, this is 160 degrees right there. Now I can find little c. I can find the distance because this is side angle side. So we can get it. Little c squared. So start and begin, start and end with your c. And then a's and b's in between. Like so. And then we need the square root of both sides. And let's plug some numbers in. So let's see what we have here. We have a little a value of 100. We have a little b value of 200. And we have the measure of angle C at 160 degrees. And that's what we need for this formula. So we will have 100 squared plus 200 squared minus 2 times 100 times 200 times the cosine of 160 degrees. And I better move that down so I can see all those zeros. I'm punching everything in. 100 squared plus 200 squared minus 2 times 100 times 200 cosine of 160. And second square root of that monster, 295.952. And let's see, miles? Or did they give us European kilometers here? Miles per hour, so this was in miles. All right, so there's the distance. So we're about halfway there. We have to get bearing. So this again, you try to figure out from due north, bearing and heading, or from due north, how are we going to get this person to go from here to here? That's what we really need. Well, this is 180 degrees, this straight line. So if we can figure out what this is, and I'm going to call this angle beta, I'll use a Greek letter for that one, then we'll have it. But, well, that's not information that we have right now. You know, we don't know what beta is. So can we figure out what this angle is? Sure we can. I'm going to put theta in there so that we've got a little something extra going on here to talk about what's going to happen with these angles. And would that be enough information for us to figure out beta? It would, but we better take a little magnified look at what's happening at vertex B up there. There's vertex B. There's due north. We know we need 180. And we know we need whatever this little beta is here. We can find theta. We can find the measure of angle B by using the law of cosines right now. But there's nothing here to help me out as far as, hey, do these add to 90? Do they add to 180? Until I put my compass settings on. Because then I remember the change in heading right there was 40 degrees. And since this is a right angle, that little angle right there is going to be 50 degrees. Pardon me. So if I figure out what theta is using the law of cosines, then I can take 90 degrees minus 50 minus theta, and that'll leave me that beta piece that I need. So now my focus is on finding what is angle B way back up there. So we're going to have to use little b and end with big B. And use A's and C's in between. And we have to get that solved for the measure of angle B. So let's get cosine of B alone first. And then remember that to find the measure of angle B, we're going to need to do inverse functions. Like so. All right. So let's start putting some things in there. I know I wrote them up here. We had A at 100, B at 200, the measure of angle C at 160, and then we had little c at 295.952. And now that I realize I'm going to have to use little c, I'm going to store little c. So there's little c sitting there. Store, whoops, not second, alpha. So it's in there and ready to go. All right, time for some numbers. Inverse cosine of B was 200, so 200 squared. A was 100, minus 100 squared. And little c was our 295.952 squared. All over -2 times 100 times our 295, blah, blah, blah. And that will give us the measure of angle B. And I hope that's low enough that I can see it. Nope, got to go down a little bit more. Parentheses, 200 squared minus 100 squared minus alpha C squared, parentheses, divided by parentheses, -2 times 100 times alpha C, parentheses, inverse cosine of that big mess. 13.364. degrees for the measure of angle B. Now, I'm going to need that again because remember, we haven't found beta yet. So, and it is the last thing we punched in. We probably wouldn't have to store it, but better safe than sorry. Store alpha B. Because again, this is 50. This we now found at 13.364 degrees, but those weren't the ones we really need. We need beta. So we need 90 minus 50 minus 13.364 degrees. That'll give us our beta. So 90 minus 50 minus alpha B. 26.636 degrees. Whew. Almost done. Because now we know what beta is. But remember, we had to go from due north. So we need 180 plus our little beta piece. After all that math, we probably better write a sentence here letting them know exactly what they wanted. So here's how they worded it. In the morning, when he leaves his house in his plane to return to the airport, on what heading should he fly to get there directly? His heading should be 206.636 degrees for a distance of, oh, let me go back and find that one. Little c, 295.952 miles. Because that was a lot of math and a lot of pictures. And like I said, when you have problems that involve bearing or heading, put those compasses on there. Put that north, south, east, west on there because that breaks it up into workable pieces because there's a lot to figure out. So that definitely hit our objective of, work with the applications because there was a lot there. And then they give us another one where the drawing's already made for us. But that's okay. In your homework, I remember a lot of them have the drawings already with. It just shows you how you can use these. So the bases on a baseball diamond are 90 feet apart. So they already have that labeled there, but it'd be 90 feet all the way around there. And the front edge of the pitcher's rubber is 60.5 feet from the back corner. They already have that labeled for us right there. Find the distance from the center of the front edge of the pitcher's rubber to the far corner of first base. Well, they even put the angle on there for us. We need C. So really what we're just checking is, does this fit law of cosines? Side, angle, side. Sure does. We'll put it in the formula. We need little c. Start and end with C. A's and B's in between. We're going to take the square root of both sides. and we'll see what we get. So let's get things labeled here. Little a is 60.5, little b is 90, and the measure of angle C is 45 degrees. I can already hear you tapping away on your calculators. Good, that tells me you're feeling comfortable with all of this. 60.5 squared plus 90 squared minus 2 times 60.5 times 90 times the cosine of 45. And let me double check it, because last time I punched it in, it missed the decimal. Nope, I hit it hard enough this time that it took it. And then second square root of that answer. 63.717 feet. So again, it's an application. It is a word problem. They gave us the picture. I mean, that really helps when that picture is there. So let's review. Now that we've spent 5.5 and 5.6 talking about law of sines and law of cosines, let's go back to 5.5. Again, what three triangle setups are going to allow us to do law of sines? Angle, side, angle. Nope, that's this one. Side, side, angle, the ambiguous case. Yeah, the stuff with two angles. You know, that's the one. Angle, side, side, angle, and then angle, angle, side. So ambiguous case and stuff with two angles. What two situations for law of cosines? Side, angle, side. Side, side, side. All right. Now, like I said, tomorrow, one way or another, there'll be some kind of video for the exploration that we don't have done yet in the notes. That's it. So I would definitely recommend rewatching 5.4 if you haven't already. You won't need the exploration to do this homework for the second day of 5.6. But I'll be doing that exploration, like I said, one way or another, on a video. Get the lights up for you.